All right, here we go. This is 7.3 day number 1. We just watched Joey Chestnut eat 61 hot dogs in 10 minutes, which is 6 hot dogs a minute, which is 1 hot dog per 10 seconds, which is awesome. Let's talk a little bit about today and word problems, inequalities, all sorts of good stuff. Here is the setup for the lab. We're going to do that next week. All right, let's talk about this here. Joey Chestnut, we wanted to go with around 70 here. Joey, let's drag this out of the way. I want to move those hot dogs. Oh, hello. Hi, thank you. Yeah, no problem. We're going to talk a little bit about solving some rational equations. So let's talk for a moment. Let's talk about the rate at which Joey was eating hot dogs. Right? He ate 70 hot dogs in 10 minutes. We know that Ernie, we know a little bit about Ernie. We know that we want to know how many or how much time it took him to eat 30 hot dogs. But we know together at the same time they could eat 100 hot dogs in 8 minutes. Now there's an easy way to solve this and a more difficult way to solve this. How many of you like fractions? Oh, you do? You sick individual. Of course, he's a Vikings fan. He's got something wrong in there. Okay? There's an easy way which does not involve fractions. Would you like to see that? Yes. Oh, okay. This is called clearing the denominator. What items are in the denominator? Numbers and a letter, right? Right? So if I multiply everything by 8 and by 10 and by t, watch what happens. What happens to the 10 in this term? Goes away. So I get 8 times 70, which is 560 t. Oh, that was nice. What happens to the t in the second term? It gone. So 80 times 30 is 2,400. And what happens to the 8 in the last one? It gone. So the 8's cancel, and I get 10 times 100, which is 1,000 t. Oh, much easier to work with, right? Much easier to work with. Now I can have a linear equation, right? And I can solve for t. Let's do that real quick. I like linear equations. Linear equations are my favorite. Okay, so I have 2,400. If I subtract 560 over to the right side, I'd get 440 t. It looks like t is going to be between like 2 whole minutes. I don't know exactly what it would be. What is that, like 5, almost 6 minutes, something like that? Does that look about right? What's 2,400 divided by 440? 5.45 minutes. So it would take this Ernie fellow just under 5.5 minutes to eat 30 hot dogs. That's so weak. Come on. That's weak. Nice job, Ernie. All right, let's look at another type of problem similar to. Okay, so Carl decides he's going to explore the Meander River. Oh, that's funny. The location of several recent Sasquatch sightings from camp. Let's draw camp. Can we draw fire for camp? Let's draw fire. There's the fire. That's camp. Right? It's along the Meander River. It says from camp he canoes downstream 5 miles to check out, I don't know what that word is, Sasquatch nest. Is that like potential? Yeah. Okay. So let's go down here. Let's write the Sasquatch. I'm going to just shorten it and put fear in this person's eyes. Okay. So he travels downstream 5 miles. 5 miles. To the Sasquatch nest. Finding nothing, sad, immediately returns. Retraces his route, this time traveling upstream. So he travels downstream, turns around and travels upstream. Again, 5 miles. All right, what else we got? He returns to the camp 3 hours later. Okay, so I'm going to write ourselves a little linear equation over here. Time to go downstream plus time to go upstream equals a total of 3 hours. We're going to use that momentarily. If Carl canoes at a rate of 6 miles per hour in still water, how fast was the Meander River flowing that day? So let's talk for a second. Carl is traveling at 6 miles an hour the whole time. No muscle failure at all. He's just solid. 6 miles an hour, whole way. Okay, when he's traveling downstream, is the speed of the stream helping or working against? Helping. So his speed over here, going downriver, would be 6 plus, let's say C is the current speed. How would I write an expression on the other side? 6 minus C, right? 6 minus C, because he is traveling faster than the current because he can get home. So the speed over here is 6 minus C. All right, now what equation are you familiar with regarding speed? What does speed equal? Distance over time. Okay, in this case, look at this. I have time and time and time. So I want to rewrite this in terms of time. What would that be? Time equals what? Distance over speed. So let's come up with a time downstream and a time upstream. So a time for going downstream would be distance, which is, what is the distance? 5, over speed, which is 6 plus C. Time upstream is going to be just a tiny bit different, same distance of 5, but now the speed is 6 minus C. Now we can do some work. Time downstream is 5 over 6 plus C. Time upstream is 5 over 6 minus C, and total time would be 3. Now, in the last problem, we talked about just totally demolishing some hot dogs by clearing the denominator. How would I clear this denominator? What's in the denominator? Six plus C and 6 minus C. If you thought the quadratic formula was going to go away, you'd be wrong, child. You'd be wrong. Let's figure out what's going to happen here. If I multiply by this term, the 6 plus C will disappear, and I'll get 5 times 6 minus C. If I multiply by this term, I'm going to get 5 times 6 plus C. And if I multiply 3 by that, I get 3 by that. All of this so we can just figure out how fast the Meander River is flowing. Are you kidding? No, I'm not. This is awesome. All right, so something really nice happens here. I get 30 minus 5C, and I get 30 plus 5C. Those 5C's. Oh, I feel kind of bad. You're a 5C. Yeah, you're a 5C. But those 5C's are going away, and you're going to go away for 4 days. I hope you come back on Monday. So I'm left with 60. I'm left with 60 on the left. And on the right, I'm going to do a little expansion. All right, this would be 3 times the quantity 36 minus C squared, which 3 times 36, I think, is 108 minus 3C squared. Oh, we're almost there. What do? Subtraction. I subtract the 108, and I get a negative 48 equals a negative 3C squared. I divide. Oh, that's a nice number. Thank you. Oh, what's the speed of the current? 4. Well, plus or minus, but the current can't move at a negative rate, so we're going to say that the river was flowing at 4 miles per hour. Those of you on the web, this is going to be group work time, so take a moment, pause this, and come back and check your answer. Oh, Taylor and Carl. Taylor and Carl. How long would it take for Carl to weed the garden? Let's see. Clear the denominator, Carl. Clear it. Clear it. Clear the denominator, Carl. Okay, Carl. No, I was talking to someone else over here. Yeah, I mean, that's a really small garden, but it looks like it's meticulously groomed. It looks like it takes Carl 12 hours to garden. He must be getting lost in there and like finding worms and putting them in Taylor's pockets, right? Save them for later or something. Oh, Carl, 12 hours. That's pretty slow. Okay, so we're back, guys, and we skipped the box problem. I'm going to make a video of that for you. We are going to solve this. Where is 2x plus 17 over x plus 1 equal to x plus 5? Well, I can tell you one place that it's not equal. -1, correct. So what I want you to do at the very beginning is if you have a rational function like you do over here, I want you to find out values that x cannot equal. Okay? So if you're tempted to say, oh, it's -1, it's not, child. It's not. All right, now, next thing I want you to do is cross multiply. Well, if I cross multiply, I get 2x plus 17 times this 1 down here. And I get x plus 1 times x plus 5, which is x squared plus 6x plus 5. I'm so good at foiling. I practiced all day yesterday. Do you believe me? Yeah. Yeah, I nerded out. Protein shakes and cross multiplication. Okay, now I'm going to get everything on one side. If I do that, I get x squared. Looks like plus 4x minus 12. No, because I'm going to subtract that 17 over here. I get minus 12. Can I factor that? I hope so. Otherwise, I got QF in my back pocket, right? Quebec Fox, the old quadratic formula. All right, that's always available. Let's do this. Let me drag this little icon over here. Ooh, that's cool. Two numbers that multiply to -12 and add to +4. I know what they are. Plus 6, minus 2. Chow, where are they equal? They're equal at x equals -6 and x equals 2. Now I go back because I forgot the bread downstairs when my wife asked me to grab it last night, and I came back up with an empty can of dog food. Yeah, she said, go down and grab some bread. And I went down and I fed the dogs and came back up with the can of dog food. Right? She's like, where's the bread? Oh, forgot. I forgot within 3 minutes what I was going down there to do. So within 2 minutes, I forgot for a moment that x can't equal -1. So I'm going to go back. I'm going to check to see. Oh, good. Neither of those is -1, so I'm solid. So I'm solid. Those both work. They're not part of the restrictions on that formula or that function. How's that feel? See? Buenos dias? What if I did this to you? What if I threw an inequality in there? Ooh. Ooh, it's the same thing, except now all you're going to do is test around the values where it equals 0. And then you test between those values. So, example, where would this thing be equal to 0? Oh, my. Well, let's do this. Let's take this. Let's find where it equals 0. Okay, let's find where it equals 0. Where would it equal 0? Well, I'm going to cross multiply. So I get x equals, 0. It only equals in one spot when x equals 0. Oh, so then I draw myself a number line where this is 0 at 0. And then I'm going to test to the left and to the right. Let's test 1. Let's test the number 1. If I plug 1 into this equation, I get 1 over 1 squared minus 1. Uh-oh, we got a problem. What did we not do at the beginning? We didn't look for the gaps in the domain, right? X can't equal -1 or 1. So I actually have asymptotes at 1 and at -1. So the number of intervals you have to now test goes from 2 to 4. From 2 to 4. Why? Because I got to know what the function does here. Is it greater than 0? I don't know. I got to plug in a number to the left of -1. I got to do the same thing here. I got to do the same thing here. And I got to do the same thing here. So in the end, let's see what happens. Let's plug in a -2. If I plug in a -2, I get this. And that makes that 4 minus 1. So I get -2/3. So in this section right here, I get a negative number. It's below 0. What happens if I plug in a -1/2? Sorry for all you folks who don't like doing work. Plug in a -1/2. That's a negative. What will this down here be, negative or positive? If I square -1/2 and subtract 1, will this be negative or positive? Negative, so it'll be a negative over a negative, which will be a positive. Okay, how about 1/2? So I make that a positive and make that a positive. That'll be a positive over a negative, which will be a negative. Let's put that in green. And if I plug in, let's say 2. Let's plug in 2. Who's making popcorn? Oh, okay. 2, and 4 minus 1 is 3, so I get 2/3. Oh, I get another positive. You better be good, popcorn. So along this number line, I knew 0 equaled 0. I knew there was an asymptote at -1 and an asymptote at +1. I knew it was below here, above here, below here, and above here. How would we write an inequality for that if we want to know where it's greater than 0? Or we could write it in interval notation. Well, let's highlight the values for x that are greater than 0. How would I write an interval for that? -1 to what? To 0. Parentheses or brackets? Parenthesis. Union. Parenthesis, what number? 1 to what? Infinity. Ciao. I know where that rational function is greater than 0 on that interval. Ciao. All right, like, subscribe, comment. I'll be coming up, 18 minutes. Oh my gosh.